find are interesting. And I'm glad they're the same things I find as interesting too, because that validates my curiosity. All right, the first thing is that you have to, just to remind you again, when you go back to look at this video for your project, the first step is to set the working directory to the folder that you have the data in.
Yeah, what is the title of the, on YouTube, what is it titled?
What?
On YouTube, what is it titled?
Should I title it our explanation that's needed on projects so you can dig it up easy?
Our project setup.
Okay. Call you. Okay, all this header stuff, if you highlight them all at once and do Control-Enter, that loads all those library packages at once. I'm going to read the data. So this is the data that they have in your book. It's on a certain page. They actually have the sleep deprivation data. And if you notice, one of the first things that hit me is that, hey, it's a really small study and they got it published in Nature. Wow. But these studies are really hard to do. Making people do something is hard. You know, I could have just as much luck. These are all volunteers. Let's suppose I wanted to run a study and say, hey, I just like to see how if I give people this treatment, if their integration skills will improve. Let's see how many people sign up for that one. And I'd have to supervise them, right? Because otherwise they won't do it. So then they'll drop out. They're volunteers. Same with exercise. Same with sleep deprivation. Someone has to sign up for it. All right. So I'm going to load that data set in there. I always go click on that to make sure I see what's in there. So what I did is I put the unrestricted group improvement scores and the sleep deprived, I should have put improvement scores, I did not. And then I have the change score and type is unrestricted, and I put them all in one column with the type so I can do some graphics and see things. You can do the same thing and you can do it all in Excel. I just did this in Excel and made it look the way I wanted it to look. The reason I did this, so in this change score thing, the type is unrestricted, and then I also have below that sleep deprived. So I can graph the two types against each other and see with my eyes. Those are the kind of figures you want to put into your project. So let me go forward with what kind of figures I'm going to make. The first one is I showed you this GG line thing. So one of the variables I have in the data file is type, whether they were sleep restricted or not. And then I want Y to be the change score, but I want them to separate them by unrestricted and sleep deprived so they bunch it up and I can see that data against each other. And so when I do this, I get this. So unrestricted sleep, that these are the people who got to sleep how much ever they wanted to. Not you. Maybe you on vacation. So this is, you can see now the difference, right? You see the trend in the line that this sleep deprived group, their change score is smaller, which is what I was pointing out to you, that there's less improvement if the change score is smaller, and there's more improvement if the change score is higher. Now I can see that difference. So what would you interpret from this figure?
That receiving more sleep allows you to improve better on the test.
Yeah, being unrestricted, right? And being able to sleep is how much your body wanted to, will let you do better on this test. And being sleep deprived makes you do worse. Something to think about before TEAS. The next thing is I use this to describe. If you only have a few columns, the describe command just gives you the means of all those things. So I'm going to spit that out to show you what that looks like. And it gave me some red, but above it, I have what I need. I just want the means. And so if you go look here, the mean of the unrestricted group was 19.82, and the mean of the sleep-deprived group was 3.90. Can I say from this information alone that the two groups are different?
Yes.
You sure about that? You're 2-6Y.
No.
What is like, how do we decide whether to reject the null and all that stuff? P-value. So we need to go forward and actually have some statistical tests. I tweeted about this the other day. When we talk about stuff being true or not, in math it's a proof. Pythagorean theorem, twin prime conjecture, separated by tags. Here I don't have, this is just evidence to support the conjecture. That's what this is. I need some statistical tests to prove what I'm trying to say. And it's not quite like a mathematical proof, but that's as close as we can get. Karl Watts says that's what mathematicians are most uncomfortable with, and I was very uncomfortable with that, that I can't prove it. So, a little trick. So you don't have to keep using the data, like you can do some work. You can just attach the data so that it makes this part easier. So what this is called linear regression. And I'm not going to go through theory, but you're basically fitting that data to a line. It's the best fit line. You've done this in your lab classes. If you've had a lab class in Excel, the trend line. You did it in 103. Remember doing that in 103? I know when I'm boring because everybody's looking at the clock. You did it in Jedi Math. I'm pretty sure you did some line fitting. I should know that. I taught that before. So you have data, and then you want to put the best fit line through it. And that's what you're getting. In one sense, that's what you're getting. So you can have as much and as many variables as you want here. It doesn't have to be one variable. I'm just going to do one variable to show you one, but in your project, you're required to have more than one. So for example, prior service, you can put age and gender as some additional variables in there to test out where there's a difference. And these coefficients tell you something, so I'm going to show you how to interpret them. This is the command, LM, linear model. The response variable goes first. So I want my response to be the change score as you told me earlier. All those decisions have to be made in advance. And sometimes you look at the data and realize I don't have what I need in the data, so that's not what I mean. You can't make the LM and go, I didn't get what I want. I'm going to go back and change my hypothesis. You can't do that. That's not allowed. You have your hypothesis and then you write this down. So then I want the x variable to be the type. It's what we call an indicator function. I don't have to code it until it's a 1 and 0. It will automatically do that for me. So if I do Control Enter on that, oh, I didn't like that. There we go. So I'd have to do that attached data first. And then if I do the summary model, it gives me a bunch of stuff down here. Let me pull this up so you can see it. So here's what it's telling you. Is this the board that over here that you guys can see best? So this is the beta 0, 3.90. So it's like you can think of it as a prediction model. I'm giving you some bad notation here, but this is ultimately what it is. 15.92 is the slope. And the y-intercept is 3.9. So it's a prediction model with sleep-deprived and not sleep-deprived being the x variable. And they tell you a few things here. First of all, they tell you this coefficient is significant. This is the p-value.